So, and then you connect it to a PC
Mm.
and you can instantly start the communication, in this case with the LCD display. So this, 7-segment display, and you can start the communication there. Just to give you a use case there. So imagine you have a temperature sensor in your system.
Okay.
And you want to test it, want to do a continuous integration there with your embedded system where you use the temperature sensor. If you connect the real temperature sensor, you have the problem that how do I change the temperature? How do I go to the warning threshold and so on?
Okay.
And that's possible with our device.
So, ipXchange audience, welcome to another IP experience, this time with Eamon, and again with Klaus from Semify. So last time we talked about the motor shield that Semify make that's kind of a more powerful alternative to Arduino's normal motor shield, but this time we're talking about SmartWave, I believe?
That's right, yeah. So this time I want to introduce SmartWave and
Cool.
tell you a little bit about our product, about SmartWave, about the functionality of SmartWave and what you can do with it.
Cool. So I guess to begin with, there's nothing in the name really to suggest what it is. So what is SmartWave and what does it bring to the table?
Okay, good. Yeah, so it is there intended to allow you an instant connection to your standard interface in your embedded system. So when you have to connect to SPI I2C interfaces there, it's the fastest way how you can establish such a type of communication in order to test out the different stuff like temperature sensor, LCD displays, accelerometers, whatever you can think of. When you're in the testing phase, you want to evaluate it, you want to test different products there, then it's SmartWave is the right tool to use
sounds
and to try.
Cool. So that sounds like what you were saying last time, that Semify makes tools that help design engineers solve their problems. So in terms of applications, that sounds very very much you can use it with a lot of applications, because it seems to be for basically any connect. Is that right, that it's for basically connecting any interfaces to your embedded design?
So currently we are supporting SPI and I2C, which are the first interfaces we are supporting in our first device. Nevertheless, in the background of our SmartWave device itself, we have a FPGA-based platform there, which allows to directly connect to the PC to your web browser, so you don't have any software to install. And step by step, we will then enhance the interfaces we are providing. Let's say, highest probability, what we are working on next always depends on the requests of our, let's say, customers. But obviously, UART interface is the one which is also, let's say, requested, and most likely this will be the next interface. There are some more interfaces in discussion, but So for now, we support SPI, I2C, GPIOs, and the next we will see what's coming next there on interface perspective. Nevertheless, we permanently increase our functionality, our features there, which is very easy to roll it out, as we are a pure web-based interface from software perspective for the user interface. And we can also update our firmware, our FPGA programming also over the web interface. So you can receive permanent updates there and permanently get a better device step by step.
Cool.
Yeah.
So in terms of what it looks like in hardware, is it a little box? Is it a board? Do you Oh, okay.
It's a little box like here. I didn't prepare a demo for you, but it's easy. Okay, so it's a little box like this. You have on the side, just give me a second. You have, I tried it today in the lab, something, that's why it's taking a little bit longer. So basically what you see, you have two of these Pmod connectors here.
Okay.
They're not standardized, but they at least are specified by Digiland in a way what the distance there is, how the pins are connected there, which provides you to offer now from our side 16 GPIOs or 16 functional pins, which we can assign to any functionality there. And we have, in addition, a power and a ground pin, whereas the power supply, the VCC, can also be changed over the web GUI in a range from 5 to 1.8 volt there. And then you can assign each pin to the functionality you want to have. So you can have 2 I2C interfaces and 2 SPI interfaces and a few GPIOs, whatever you need in your application.
So
that's about the device.
Would you, in that case, would you describe it as an I/O expander? Would that be accurate?
I think it's more than an I/O expander. So it's let's say a general tool to handle the interfaces. So it's more than just I/O expanding, because it also provides the functionality behind it.
Shifting for different I/O voltages, that sounds pretty good. That's very useful.
Yes, depending on the application, you might have 3.3 volt applications, you might have 1.8 volt applications, or you want to try some levels in between. This you can you can easily update the value in the GUI, and the value changes then immediately.
Cool. So I guess if it's using kind of Pmod-style connectors, does that mean you can just use it with kind of your development board of choice while you're developing, or what's a typical setup that you'd connect the box to?
Okay, yeah. So what's a typical setup to connect the box with would be, didn't prepare a great demo, but easily connection is you have something like this. This would be just some LCD displays there, and you just, let's say, connect the pins here one to one, like this to the box. On the other side, you put your I2C, USB interface. Sorry. You have to put it directly. So, and then you connect it to a PC, and you can instantly start the communication, in this case with the LCD display. So this 7-segment display, and you can start the communication there. Using the web GUI, you have a nice display as well there available, in order to also have the possibility to see the pin assignment which is used. So just to give you, it's not so easy to do it on the small camera, but what you see here, it's hard to get it sharp, but you see the pin assignment. Yes, it's a screen. Yeah.
Oh, wow.
Course,
okay.
Yeah. So.
Nice.
Yeah, so, and when you connect to it, of course, you can then see the pin assignment there, so you don't need to still count the pins there. You have a single button there on the right there, which can be configurable in the sense of, now the cable is too short. You have a single button here, where you can start and stop and perform, let's say, configurations or trigger events. So that's basically configurable what you can do with this button. So it's all made in the sense of, let's say, making it more usable, have a great user experience, a usability, and make it easy to use. So that's also one of our, let's say, main goals, what we want to achieve with this device. Mainly triggered by issues I have seen in the lab over my past 25 years of experience as an engineer, where I always had issue and complaint with it. Try to fix it all inside the device.
Cool. So, I mean, from our chat so far, I'm getting the impression, but I might be wrong, is is the main aim to build products around SmartWave, or do you use it to do you add it to a design to give it more functionality?
So basically I see two main applications. So the first application is when you are exploring a system and you test different devices, different sensors, stuff like this. Then you want to easily connect them, try them. So that's a very good application for SmartWave, because it's very easy to set up and start to communicate with these devices. And also on the application phase, when you, for example, want to show the customer you have a small development by yourself, then it's very easy that you can show it to the customer. You have a nice device on let's say on your desk. You only need a USB connection, the browser, and you can easily show your specific embedded system then to a customer. So this would be some typical use cases. It's not restricted to these use cases, as we also start to support an API interface, which was especially requested by some users.
Nice.
And there you can then also use it in your continuous integration. So just to give you a use case there. So imagine you have a temperature sensor in your system.
Okay.
And you want to test it, want to do a continuous integration there with your embedded system where you use the temperature sensor. If you connect the real temperature sensor, you have the problem that how do I change the temperature? How do I go to the warning threshold? And so on. Okay. And that's possible with our device in a way that we can emulate the slave or the I2C target, for example. You have a possibility to simply model the register interface, which is available in such a sensor. And then you can, over the USB interface, drive certain values for the temperature, and your embedded system can react on it.
Oh, I see.
So it's a very...
Yeah, so you can use it both in kind of almost testing... How do I word this?
Evaluation, continuous integration. So the concrete example we have is a temperature sensor is a customer who wants to or will use it in continuous integration. And there he has exactly this problem. So how do I verify that my system reacts correctly if the temperature goes above a certain threshold?
Okay, so you can use it
simulate
the. You can use it to kind of simulate the extremes of the sensor that you would connect to your system.
Exactly.
As well as integrate it into your system more effectively, because you've got all the voltage shifting or better interfacing, which might not be available in. Cool. That's wow. I wasn't expecting that.
Yeah, we didn't also expect it. It was a customer who came especially with this request, and it was due to the fact that it's a very flexible and configurable platform we have in the background. It was very easy to add this functionality for this specific customer. And that's also I think one of the strengths of our device. We are very fast and flexible in adding new functionality and are also able to customize it to the need of the customers. So if they're on the one side either require a specific interface or a specific behavior they want to implement, we are, due to the FPGA-based platform we have in our background, we are very flexible and are very fast in adapting it to the needs of a customer.
Cool. So obviously you've already mentioned that there's kind of a web-based configuration of the of SmartWave. So can you just take me through a few of the different things that you can configure, and is it pretty much easy? You don't have to code or anything, do you?
No, you don't have to. So you don't have to code. You have the possibility, or let's say the structure of the web-based interface fits very well the structure of the device itself there. So you start with the pins. Usually you start with the driver interface, then you define the interface you want to use, SPI, I2C, or GPO for now. Then you connect, you assign the pins you want to use for it. So you can use any pin for any interface. There's no fixed assignment there. So you assign the pins there. You maybe also adapt the voltage level, and then you go the next step there where you say how your driving source looks like or what data you want to drive. Do you want to have a kind of register access with address data, or do you only want to send and receive data? Then you have different possibilities to enter the data. And then you just connect to the device and click on the go button, and it's already, let's say, working.
Nice. And in terms of on the screen, on the actual SmartWave box itself, what is, I mean, we saw a little glimpse of it, but what is that displaying kind of day to day?
Yeah, so the purpose there is, for example, you see the pin assignment. So if you have the pin on A1, then it's getting a SPI clock SCL. Then it gets also the name SCL that you know that's connected to this clock. You can change the name based on your, let's say, pin names you're using. Especially SPI has different, let's say there's no standard, different names. You can give specific names there that it's fitting for you. You can see the voltage level which is used, and you can see if the device is connected, operated, so some status information there.
Cool. And I mean, since this is a device that's working with different voltages, are there any protections integrated?
Yeah, so the I/O structure, there is some protection there against ESD,
Okay.
current limitation, and so it's not. There is some protection circuitry there, which gives a protection against overvoltage and some ESD discharges and so on.
Excellent. So we've already discussed the temperature sensor application.
Yes.
So in a very broad sense, what are the applications where you see this as being a very useful tool during development? I mean, I know it's interfaces, which could be literally anything.
Yes,
but,
at the end,
yeah.
Sorry.
No, continue.
Yeah, at the end, every embedded system, what you can imagine. So it's not specifically used for any application. There are many, let's say, at the end, you're not limited by the application. It's more about wherever you have an embedded system, let's say it like this, and you develop the embedded system, it's a useful tool. So either, when you select your sensors, when you develop your own ASIC and want to start to communicate with it the first time, ramp it up in the lab, it's also very, very helpful there. That's also a use case we had already for a customer. So he developed his own sensor, I2C interface, and then in the lab for configuring his own device, he used our SmartWave because it's very fast. You don't need to develop a GUI by yourself upfront to establish a basic communication. And to set this up, you just use our device and you don't need to program anything. Cool. Nevertheless, still at the later point in time, usually the people tend to go to automatization. So that's why we are starting to offer a Python API it's not released so far, but it's in I would say, close to the first release that we can do, that you also can access all the nice SmartWave functionality via Python API and use it for automatization as well.
Cool. Well, I think that's covered quite a lot, and yeah, that sounds like an amazing device. Definitely a useful tool, but also, I think if you're especially new sensors, this could be great. And I mean, ipXchange loves disruptive sensors, so this would be able to help people simulate the limits of those sensors in their application and see how far they can push it, I guess.
Exactly, and especially, let's say, select the right sensor at the beginning, and then at the later point also use it to test your system, evaluate your system, and even show it to your customer.
Nice, excellent. Well, I think the last question I'll just quickly ask is, so you've got the SmartWave box. In terms of getting started, is there anything else you need?
No. So you don't need to install any software. You get with the box, of course, you get the required cable to connect it to your USB board. You get some cables to probes to handle the interface. So you just need the SmartWave box there, and that's it. So and you can start.
Excellent.
So even especially maybe just one small comment. So also what we have seen is there that really for starting such small system like we have here or something like this, you don't need a power supply. So because it's also available as part of the SmartWave, you just need to connect it. You connect it to your USB board, and then you connect your SmartWave to the device you're using, and then you are done, and you can start to communicate to this device.
Excellent. Well, thank you, Klaus, for taking us through SmartWave. I went in knowing, I think the only thing I knew is that it's something to do with an FPGA. But yeah, so much more than that. So I think our audience will really enjoy listening to this interview. Is there anything else you wanted to add with what Semify has got coming up in the future, or are you keeping that on the download for the moment?
Okay, yeah. So we have now the first version, which is called SmartWave Controller. Next step, of course, is adding our API and releasing the API, which is already in internally good shape in the testing phase. And then there are many ideas in the background. So there, which a little bit depends on the let's say resonance of the customers, but especially we're thinking about the we call it now SmartWave control. We are thinking about the SmartWave audio. We're thinking about the SmartWave. Don't have a name for it, but which is capable of generating pattern there, what you want to need, and similar, let's say, things like that. Maybe more going in the direction of supporting I2C, because it's we see it more and more as a new interface which is coming up in different applications and getting used more and more, also in sensor applications there. And yeah, that's the, let's say, field there where we want to go our next steps. And still we have a lot of visions in doing then some more, but this we, let's say, well, currently it's a little bit too early to talk about this topic. So now we're going, let's go the next steps. And
then we might have to have a catch up at some point.
Yeah, for sure. Yeah.
Cool. Well, thank you again very much for joining us today, and to the ipXchange audience. Check this out on ipXchange.tech, or if you're already there, head to the board page and see the write-up. And thank you very much.
Yeah, thanks a lot. Thanks a lot for giving me the opportunity to talk about SmartWave, and hope to see you soon again with maybe a next, let's say, feature, device, whatever it is.
Cool. Thank you.
Okay. Thank you. Bye.
Where my engineers at?